Hello students, welcome to my YouTube channel RD Academy. So in this video, we will be discussing an important 5 marks question for your board exam, that is the calculation of electric field due to dipole along its axial line, or the question can also be asked like calculate the electric field due to dipole at the axial point. Both refer to the same answer. Okay, so now before learning this derivation, let me briefly explain you the prerequisites that you need to know to understand this derivation. Okay, firstly, here as you know, dipole has both positive charge and negative charge, right? So the symbol E plus Q, okay, E plus Q subscript, this symbol indicates electric field due to positive charge. Similarly, E minus Q, this expression indicates electric field due to charge minus Q. Okay, so these two notations are important for us, and also the p cap. Now this p cap is the unit vector in the direction of dipole moment. Previously I have said that dipole moment's direction is from the negative charge to the positive charge. So along that particular direction, from negative charge to positive charge, the unit vector is p cap. What will be the other direction, that is from positive to negative charge? This will be minus p cap. Okay, these four notations are important, and one mathematical formula, though I will explain it to you detail in while solving the derivation. Always remember 1 by a square, 1 by a minus b whole square minus 1 by a plus b whole square is 1 by a square minus b square whole square. You can actually solve this. Like take LCM and expand the terms, multiply and cancel, you can reduce it to this expression. Okay, so these are the prerequisites that you need. Okay, so I hope there is no doubt in that. Now let us start with the derivation. First, before writing this derivation, you need to draw the diagram. Okay, the diagram carries 1 mark. Now an electric dipole, as you already know, consists of a positive charge and it also consists of a negative charge. So write that. Here you have plus Q, here you have minus Q. What is the distance between the two charges? The distance between the two charges is 2a. This point O is the center of the dipole. Now I need to find the electric field due to this dipole at the axial point or axial line. Which is the axial line? You have this line, no, connecting positive and negative charge. Just extend this line. This line is known as axial line. Any point on this axial line, for example point P on this axial line, is known as axial point. Now what is the aim of this derivation? To find the net electric field at this point P due to the charge plus Q and due to the charge minus Q. Now this point P is at a distance r from the center of the dipole. From where? From the center of the dipole. Now can you tell me what is the distance between here and here? Now if this total length is 2a, this length is how much? A. This similarly this length is also a. Okay, now this total length is r, you have a here, so this remaining length is this total length minus this length, right? So this length, the distance of negative charge from the point P is nothing but r minus a. Okay, similarly the distance of the positive charge from this point P is r plus this small remaining distance, and that distance is a. So this distance from the positive charge till the point P is r plus a. Okay, now what is the direction of P vector? That is dipole moment vector. Dipole moment vector is always from negative charge to positive charge, so the tail will be here and arrow mark will be in this direction. This is the direction of P vector. Okay, now at this particular point there will be electric field due to positive charge and also negative charge, right? What will be the direction due to positive charge? We apply superposition principle. For time being, ignore this negative charge. Due to this positive charge, the electric field at this point will be radially outward, like this. Okay, it will be radially outward. What does this arrow mark indicate? This indicates electric field due to positive charge. Similarly, due to negative charge, it will be radially inward. So at this point, what happens? The electric field will be in this particular direction. That arrow mark indicates electric field due to charge minus q. Okay, so now for this entire diagram you will have 1 mark with the correct labeling. Okay, r minus a, r plus a, r, p vector, e plus q direction. These arrow marks are also important, so pay attention to that. Next, I won't be writing the description of this diagram. Just whatever you have written here, just write that in words. Okay, for example, consider a dipole consisting of charges plus q and minus q separated by distance 2a. What is point A? Point O is the center of the dipole. It is point P is at a distance r from the center of the dipole. We need to calculate the net electric field at this point. That's much. You write that much only. Okay. Now, what is your principle of superposition? We'll see. The net electric field at point P is nothing but, look at point P. There are two electric fields, right? One is along plus Q cap. Sorry, one is E plus Q and one is E minus Q. So net electric field at that point is the vector sum of electric field due to charge plus Q plus electric field due to charge minus Q. This is your equation 1 from principle of superposition. Okay. Now evaluate individually what is electric field due to charge plus Q and minus Q. We already know the definition that the electric field due to charge plus Q is nothing but 1 by 4 pi epsilon naught, that I will write it as K. Okay, 1 by 4 pi epsilon naught times magnitude of the charge divided by, now what is the distance of point P from your plus charge? From your plus charge the distance is r plus a, so in the denominator you have r plus a whole square. Now direction, see the electric field due to charge plus q is in this direction, whereas the dipole moment is in opposite direction. It is moving from left to right in this direction, whereas dipole moment is in opposite direction. Now previously I told you any direction opposite to the dipole moment is given by minus p cap, so the direction is given by minus p cap. If you simplify, you can write it as minus kq by r plus a whole square into p cap. This is equation number 2. Now similarly, find the second one, electric field due to charge minus q. What will be electric field due to charge minus q? It will be 1 by 4 pi epsilon naught, that is k, times magnitude of the charge q is negative charge is q divided by, now in the diagram this point P is at a distance of r minus a from the negative charge, so in the denominator you will get r minus a whole square. What is its direction? See, the electric field due to negative charge is moving in this direction. The dipole moment is also in the same direction, so the direction is not minus p cap, now it is plus p cap. Okay, I hope it is clear. This is equation 3. Now substitute 2 and 3 in 1. Okay, substitute these two equations here, E plus Q and E minus Q. So now I will get the net electric field at point P is nothing but, in place of E plus Q I will write this expression, minus KQ by R plus A whole square into P cap. In place of E minus Q I will write KQ by R minus A whole square P cap. Okay, now which are all terms common here? This KQ, P cap is common. Take that outside. KQ, P cap is common. The remaining terms is minus 1 by R plus A whole square plus 1 by R minus A whole square. I will switch the terms here. So I will write it as 1 by R minus A whole square minus 1 by R plus A whole square. Okay, now how will we simplify this one? KQ P cap. Now take LCM. In denominator you will have R minus A whole square, R plus A whole square multiplied by R plus A whole square. In numerator R minus A get cancelled. Here you have R plus A whole square minus R plus A get cancelled, R minus A whole square. Okay, so now you have KQ P cap expand this one, a plus b whole square. So you will have a square plus b square plus 2ab minus, now there is one bracket, you should not ignore that bracket. Okay, expand this one by a minus b whole square, r square a square plus b square minus 2ab, and another one big bracket in the denominator. This a minus b whole square into a plus b whole square, you can write it as a square minus b square whole square. Okay, this is a mathematical representation. You can actually prove it, try to prove that. Okay, prove that a minus b whole square into a plus b whole square is a square minus b square whole square. Now next, kq into p cap is nothing but, simplify now, r square plus a square plus 2ar. Now minus into plus, minus r square, minus into plus, minus a square, minus into minus, plus 2ar. In the denominator you have r square minus a square whole square. Now which are all the terms that are getting cancelled? Plus r square minus r square got cancelled, plus a square minus a square also got cancelled. So the remaining term is kq p cap plus 2ar plus 2ar. I can write it as plus 4ar divided by r square minus a square whole square. This is the simplified representation. Okay, we can reduce this expression even further. So this is the mathematically simplified expression for the net electric field at the point P due to both positive and negative charge in the dipole. Okay, now how can we simplify this one further? Next, what we will do is, now we will consider the term for short dipole. Okay, for short dipole, what is the condition? The distance 2a must be very much smaller than r, right? So we already know that net electric field at point P is kq p cap into 4ar divided by r square minus a square whole square, right? This k I can write it as 1 by 4 pi epsilon naught. Okay, multiplied by 4a r, here you have q, right? Q into 4ar divided by, now this expression r square minus a square whole square, for a short dipole which term is lesser? This 2a is very small compared to this one r, so you can just ignore this a here. Okay, for a short dipole, since 2a is very much less than r, a square will be even further less than r. Okay, so this denominator I can directly write it as r square whole square, and the reason is, for short dipole a is very much less than r, so a square can be neglected. Now you can write it as, now you can write this expression as q by 4 pi epsilon naught into this 4a, can I write it as 2 into 2a, 2 to the 4, 4 times a into r divided by r power 4, right? So here you have p cap, direction p cap. Okay, now what is this one? Q into 2a, that is nothing but your, correct, that is electric dipole moment. So take this 2 outside, 2, this q multiplied by 2a, I will write it as electric dipole moment p times 1r, and r cube, r power 4 will get cancelled, so 2p divided by 4 pi epsilon naught by r cube into p cap. Okay, so then 2 ones are 2 twos are, you can further write it as 1 by 2 pi epsilon naught into p by r cube p cap, or you can write it as, in terms of k, 1 by 4 pi epsilon naught, you can write it as this 1 by 4 pi epsilon naught, substitute as k into q into q into 2a into 2 divided by r cube p cap. This 2a you can write it as k into p into 2 by r cube into p p cap, or if you ignore this electric dipole moment vector, you can include it here only. So you can write it as k 2p vector by r cube. This p vector now indicates the direction of dipole moment. So what does this imply to you? E net p is a positive quantity. Okay, so now this equation has two conclusions. First one is the magnitude. What will be the magnitude of electric field? It is 1 by 4 pi epsilon naught into 2 magnitude of dipole moment divided by distance where you are finding the electric field, net electric field. Now there is positive sign, there is plus p cap. So it tells you that at any point on the axial line of the dipole, the net electric field due to both of them is in the same direction as the p vector. That is, here now we have two vector, no, only E minus Q. The net electric field at this point is in this direction, E net P. This is also important for your competitive exam. Always remember, at any point on the axial line, the net electric field direction and dipole moment direction are same. This is what here that plus P cap implies. Okay, and this is the final expression. And always for your board exam, after you write the final expression, make sure you explain the terms. Explain what is E net P. Next you need to write where E net P indicates the net electric field direction at point P due to the dipole. K is proportionality constant. You can write it as 9 into 10 power 9. And P vector is the electric dipole moment. R is the distance of point P from the center of the dipole. Okay, here you should explain all the terms. Fine. So if you write this entire mathematical step with clean diagram and everything, you will get complete 5 marks. The marks distribution is like 1 mark for the diagram, 1 marks is for this entire expression, both E plus Q and E minus Q. Okay, and another 1 mark is for this expression, the simplified expression. So the last 2 marks is for the substitution of short dipole and final expression 2p by r. Okay, so I hope I am clear in this derivation. This is one of the most important derivation for your board exam. Okay, always remember, at any point on the axial line, electric field, net electric field and dipole moment are in the same direction. Okay, thank you so much. We will continue in the next video.